Oh, hi guys, welcome back. Let's go to our next geometry video. Bye, brother. Do you always have to do that? Yeah, family's important. Today, we are going to be learning about some new shapes. New shapes, huh? I like a little new shapes and new change, too. That kind of rhymed, but it almost did. Yes. So, we are going to be learning about pentagons. Pentagons? What are pentagons? That's a very good question. Today we are going to learn pentagons first. And pentagons are five-sided shapes. 1, 2, 3, 4, 5. 5 sides. Which means that it must also have 1, 2, 3, 4, 5 corners. Ooh, that's a pentagon, all right. Yes, it is. Wait a second. There's a triangle inside. An isosceles triangle inside. Because this side is equal to this side. Yes, and we can show that using tick marks. But this is not equal. So this is an isosceles triangle. And another one. But how many fit inside the pentagon? Well, for what we know, pentagons have 5 sides. And those 1, 2, 3, 4, 5 sides are all of the bases of the isosceles triangles. So, the amount of isosceles triangles is 1, 2, 3, 4, 5? That's right! There are 5 isosceles triangles that fit inside a regular pentagon. Well done! Measure the base and the height of the isosceles triangle to the nearest centimeter. Okay. Well, I like to measure, and this is pretty fun. This is only step 1 of how to find the area of a pentagon. Is this the actual way to find the area of a pentagon? No, this is an easier way to find the area of a pentagon. The actual way is much too complicated. Can we at least see the formula? Yes, I'll get it. So, the kind of problem solving we are doing is with isosceles triangles. But the actual formula of how to find the area of a pentagon is this. 1/4 times the square root of 5 times 5 plus 2 times the square root of 5 times a squared. Oh my goodness. That sounds very complicated. Yes, that is the actual way to find the area of a pentagon. But we're not going to use that formula. Because using that formula would require a lot more critical thinking, which you didn't develop yet. So, we're going to put this formula aside and do a simpler formula. Simply find the areas of all the isosceles triangles and add them all together to get the area of the pentagon instead. So, yep. This is an isosceles triangle. But if we measure it, we would be able to find the area of a pentagon. So let's approximate this to the nearest centimeter. Okay, here we go. This is, I believe, 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters. 1, 2, 3, 4. Oh, 5! 5 centimeters tall. So the height is approximately 5 centimeters tall. So the height, which is h, is 5 centimeters. So h is 5. This is h. And then the base, let's measure that to the nearest centimeter. Let's see about this one. Hang on, let's just fix the phone for a moment because it's showing complex formulas. Now, anyways, I fixed it. Now, let's find the base to the nearest centimeter. This, I believe, is 1 centimeter, and then this, and that, and that, and that. Look at that. This is logarithm of the height. So 1, 2, 3, 4, 5, 6. 6 centimeters. So the base, which is B, is 6. Yes. The base is 6 because we measured it and it was approximately 6 centimeters. And the height is 5 because we measured it and it was approximately 5 centimeters. We could do the same thing for the rest of these, but we know that they are all equal, so we don't need to draw the height and measure them again. So this is equal to all of these. So we know how to find the area of a triangle. Remember, kids, the area of a triangle is... Don't tell me, I could figure it out. Let's see, half of the base times height? That's right. The area of a triangle is half of B times H. Oh, yeah. We previously knew that. Yes, we did. The base is 6, and the height is 5. BH divided by 2 is the area of the triangle. 6 times 5 is 30, and 30 divided by 2 is 15. So the area of this triangle is 15. But what is the area of the whole pentagon? Well, since the actual way to find the area of a pentagon is much too complicated, and we're going to skip aside, we're going to be doing a simpler formula. Simply find the area of one isosceles triangle and add the areas of all the isosceles triangles together to find the area of the pentagon. Use your approximation for the area of the triangle to approximate the area of the pentagon. What does approximate mean? Approximate means find roughly the area. So that means that it is not equal, but is roughly equal. It's approximate. So we need to approximate the area of the pentagon. It may not be the exact right answer because we measured centimeters in a different way, but at least it's an approximate answer. So the answers can vary. So we know that 6 times 5 is 30. 30 divided by 2 is 15. Well, guys, there are 5 isosceles triangles, and the area of one isosceles triangle is 15. So we simply have to add 15 5 times. 15 plus 15 plus 15 plus 15 plus 15 would equal the pentagon's area in approximation, because this may not be the exact answer, but we're just estimating. So what is 15 plus 15 plus 15 plus 15 plus 15? Well, for all we know, 15 plus 15 is 30, and 15 plus 15 is 30. So 15 plus 15 plus 15 plus 15 plus 15 could also simply be 30 plus 30 plus 15. 30 plus 30 is 60. And what's 60 plus 15? Well, 60 plus 10 is 70, and 70 plus 5 is 75. The area of the pentagon is 75. That's right. The area of the pentagon is 75. And how do we know that? Let's review again. Area of a triangle is half BH. 6 times 5 is 30. 30 divided by 2 is 15. The isosceles triangles' areas are also 15. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75. So that's why the area of the pentagon is approximately, but not exactly, 75. So this may not be the correct answer, actually. Yes, but it is an approximate answer. Remember that. So to us, it's correct. But to other people, like you, this may be incorrect, because the centimeters that we measured may either be too small or too big. So the actual answer is different than our answer. But you see where I'm going with this, do you? The area of a pentagon is easier enough to find, and not the actual formula, because the actual formula, whew, I could tell you, I already showed you the actual formula, and it's way too tough. So, this is an easier formula with isosceles triangles. Now, the next thing we're going to learn about is a hexagon. A hexagon? What's a hexagon? That's a very good question. A hexagon is a shape with 6 sides. 1, 2, 3, 4, 5, 6. 6 sides, which means that it must also have 1, 2, 3, 4, 5, 6 corners. Oh, yes. Estimate the area of the regular hexagon by finding the area of the isosceles triangle. Show your work. Okay, so again, as with all other shapes, the area of a hexagon may also be difficult, because the actual way to find the area of a hexagon is also complicated. Are you ready to see it? The actual way to actually find the area of a regular hexagon is this. The area of a regular hexagon is 3 times the square root of 3 divided by 2 times a squared, which is a lot of work. But trust me, we are not going to be using that formula, because that one is way too complicated. Instead, we are going to do what we did to the pentagon, and find the area of one isosceles triangle, and add all of the other areas together. So, let's approximate this in centimeters, which means that although the answer may or may not be correct, it is an approximate answer. And, as we see here, it's an estimate. So, estimate. So, the answer can vary. Let's just do our best, okay? Okay. 1. And another is 2. Next comes 3, obviously. Oh, would you look at that? 1, 2, 3, 4. 4 centimeters this way. So, B equals 4 in this case, because we approximately measured it to the nearest centimeter. So this is 4. But what about the height? Okay. 1, 2, let's see, and 3. 1, 2, 3, but this final line over here is too short. So we could say it's approximately 3 centimeters. So the height is approximately 3 centimeters, because this 4th line is too short. So this does not count as 4 centimeters. This approximately counts as 3 centimeters. Now we know what to do. 4 times 3 is 12. 12 divided by 2 is 6. The area of these isosceles triangles is 6 too. Let's draw them. Isosceles triangle, isosceles triangle. Oh yeah, oh yeah. Okay, review. This is a triangle. This is a triangle. This is a triangle. That's 3. This is a triangle. This is a triangle. And that's a triangle. 6. So, in a hexagon, there are 6 isosceles triangles. Very cool. Well, as we know, the area of one of the triangles is 6, because 4 times 3 is 12, and 12 divided by 2 is 6. So guess what? We have to add 6 times, because the area of these triangles is also 6, because 4 and 3 are the same here. 4 times 3. Let's just double check if we did it right again. Last time. 4 times 3 is 12. 12 divided by 2 is 6. We are right. These are also 6. So we need to add 6 times. Are you guys ready? Yep. 6, 12, 18, 24, 30, 36. Guess what? The area of the hexagon is 36. Wow. Do you remember why? Yeah. Because the area of this triangle is 6. 4 times 3 is 12. 12 divided by 2 is 6. Which means that the areas of all of these triangles must also be 6. 6 plus 6 is 12. Plus 6 is 18. Plus 6 is 24. Plus 6 is 30. Plus 6 is 36. So, yes, after all, there are 6 of these, and the area is 6. So you could basically just multiply 6 by itself. 6 times 6 is 36. Plus, what you can see here, 3 times 6 is 18. Another 3 times 6, which is another 18. 18 plus another 18 is 36. So, the area of the hexagon is 36, but the area of the pentagon is 75. Which area is bigger? The area of the pentagon or the area of the hexagon? Ooh, the area of the pentagon, which is 75, is greater than the area of the hexagon, which is 36. Although a pentagon has more sides than a... Wait, more. A hexagon has more sides than a pentagon. Silly me. A pentagon has less sides than a hexagon. What was I thinking? Although a hexagon has more sides than a pentagon, this hexagon has a less, and this has a more. Pentagon has more area than hexagon does, although hexagon has more sides than pentagon. Very cool. It's basically because B and H are typically less than these two. So, yeah. Very nice. This is going to be a toughie. Okay, hold on to your seatbelts. The area of this hexagon. We are going to do a lot more thinking here. Okay, let's draw the triangles again. Swoosh, swoosh. Do-do-do-do-do-do. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Oh yeah, these are triangles. It's a hexagon, all right. Okay, let's put our thinking caps on. The area of a triangle is half of the B times H. 12 times 10 is 120. Divided by 2 is 60. And the areas of all these triangles must also be 60. So guess what? We have to add 60 6 times. 60, 120, 180, 240, 300, and 360. The area of this hexagon is 360 square centimeters. Wow, very cool. Very cool indeedly. Yes. Let's go to the next page. Okay, hold on. We have to get rid of this formula because we are not using this formula. This formula is way too complicated, so let me get rid of that one. There we go. Okay, anyways. Last but not least, we're going to learn about octagons and regular polygons. Excuse me? What's an octagon? That's a great question. An octagon is a shape with 8 sides. Oh, yeah! Like the shape of a stop sign. Yeah! And pretty much the shape of some windows. Yes! Some windows and some stop signs are octagonal in shape. Great job. Octagons have 8 sides and 8 corners. You know what to do. Find the area of the octagon. Let me guess. The actual way to find the area of an octagon is more complicated than we think. Yes. The actual way to find the area of an octagon is a lot more complicated, but we're not going to be using this formula. I'm going to show the formula to you, but we're not going to use it. We're going to use an easier formula. The actual way to find the area of an octagon is by doing this. The area of a regular octagon equals 2 times 1 plus the square root of 2 times a squared. Again, as I said, we are not going to be using this formula because it's too difficult. Instead, we're going to be using a simpler formula, the isosceles triangle formula. So, let's get right to work. Let's put our thinking caps on. What's the area of a triangle again? Half times BH. That's right. 4 times 5 is 20, and 20 divided by 2 is 10, which means that these must also be 10. And since an octagon has 8 sides, we have to add 10 8 times. 10, 20, 30, 40, 50, 60, 70, and 80. The area of this octagon is 80 square inches. And how do we know that? 4 times 5 is 20. 20 divided by 2 is 10, which means that these must also be 10. Add 10 8 times. 10, 20, 30, 40, 50, 60, 70, 80. this is 80 square inches. So the area of the octagon is 80 square inches. Wow, you did that very quickly. Yes. And the last thing we're going to learn is how a regular polygon works. So, usually, we have talked about a lot of polygons, like pentagons, hexagons, and octagons, which we clearly talked about. But did you know that a pentagon could also be regular? Oh, wait a minute. I think we already saw that. Let's turn back to the pentagon. 1, 2, 3, 4, 5. Regular pentagon. Yes! But what's a regular polygon? A regular polygon is a polygon that has all sides the same length and has all corners the same too. So, basically, a regular polygon has all sides the same length and also has all angles of the same measure. So, let's check out over here. 1, 2, 3, 4, 5. Since these are all the bases of the isosceles triangles, all of the sides of this pentagon are equal in length. So this is a regular pentagon. The angles, 1, 2, 3, 4, 5, are almost the same identical curve, but tilted. So the angles are all the same too, especially since this is an isosceles triangle. An isosceles triangle has two angles of equal length, too, and angles of different measures. So, these are all the angles of the isosceles triangles of the pentagon, too. Sides of the same length, angles of the same measure, makes a regular polygon. So, a regular polygon is, everybody, a shape that has all sides the same length and all angles the same measures. That's right! Yay! Woohoo! And that is all we are going to learn about today. Let's close the book. Anyways, that's it from us today. I hope you enjoyed the video about regular polygons and how pentagons, hexagons, and octagons could be in daily life. Is there a 7-sided shape? Yes, there is. A 7-sided shape is called a heptagon, but we're not going to get into that because we are not going to review that. Bye, everyone. See you next time. Bye. I wonder what the area of a heptagon is. Oh, trust me, the actual formula is more complicated than that. That's the formula! You've got to be kidding me. This is complicated, but we could use our isosceles triangle formula, which is 5 times 2 is 10, divided by 2 is 5. And then we